So now how we write a recursive function for it. So let's just write down what we are looking for in the comments here. And we are going to type that we are going to find the sum of 1 plus 2 plus 3 plus so on up until a given num, right? So the function will get this num as a parameter, and it will return in a recursive manner the sum from 1 up to this given num. So we know that the function will receive as a parameter some integer, right? In this case, num is an integer, so we know it will be an integer, and also we know that the sum, a sum of integers, is also expected to be of an integer type. So that's why we are using the function type as int, so int, and let's call this function as we called it previously, sum up 2, okay? And in the parameters we are going to specify int num. So I hope that's clear so far. We just created our signature for this function, and now in the curly brackets we are going to specify how this recursive function will work to find out this sum. And we know that the sum of all the numbers from 1 up to num, we can say that it will be equal to, we said it previously, it's just a quick reminder, to the sum of 1 plus 2 plus 3 plus so on, right? Plus num minus 1, plus, and we separate it as just num, okay? So it's the same sum, we're just separating it that the total sum, the bigger problem, equals to some smaller problem, right? The sum up to num minus 1, all of this sum, plus this given num. Okay, we just kind of extracted from a problem that is less than the given problem, the big problem. Okay, so we have the big problem, okay, the sum from 1 up to num. And we divided, as we said previously in the introduction videos, we split it into some smaller problem, right, from 1 up to num minus 1 plus this given num, okay? So we created a little sub-problem from this given problem, and now we want to see how we can specify it. So basically, we know that a recursive function is just a function that calls itself, right? And we know that a function, sum up to, knows how to find the sum up to a given num that it receives here, up to a given num, from 1 up to this given num. So we will say that this function will return, right? It will return num plus, we said num plus, the sum up to num minus 1, as you can see here. So it will return the num plus sum up to num minus 1, okay? So we extracted this num, we extracted it, and we are using a recursive function call to a sub-problem where we are going to call and find the sum up to this num minus 1. Okay, so if we are going to run this function right now, let's give it a try. For example, we will initialize, let's just declare it. So int num, and we know that we will print some nice message to the screen, enter your number, and then the user will insert his number, and let's use, instead of enter, insert your number. So now we are going to use scanf %d and read it into num. And we want to receive the final result from this function, sum up to given num returns a result, right? So we'll create another variable and call it result, and here we will call this function, so result equals to sum up to this given num. So for example, if the num was 3, then this function we expect it to return 6, right? 1 plus 2 plus 3. And now let's try to print out the result. So printf result equals to %d, right? And we are going to just see what the result is. So let's build and run it. So build and run, and enter your number. We are going to insert 3, for example, and let's see what happens. And basically nothing happens, and it seems that our program got stuck. Okay, we received some value that we didn't even expect. Something went wrong here, right? We expected that there will be just a message with the result equals to 6, and we got something very, very strange here. And let's see and try to understand what was the problem. So what we are doing here in this line, we are calling the sum up to this given num and given here a number of 3. So sum up to 3 will return 3 plus sum up to 2. And this recursive call calls another instance of this function with the number 2. So sum up to 2 returns 2 plus sum up to 1. And there you go again and again and again. And it's kind of an infinite recursive function call. There is no stopping condition. We just will call it for a sum up to 0, sum up to -1, sum up to -2, and so on. There is no end to it. And the function will eventually not return us anything because it will never stop. It will never reach some stopping condition. So that's why we are going to use our base case, okay? We know that there should be in a recursive function some base case, some stopping condition that tells when we should stop the recursive calls. And in this case, it will be simply when this given num, sum up to, and a num equals to 1, because we know that it's straightforward that sum up to 1 is just 1, okay? And we will use this condition if num equals, for example, equals to 1, then in this case we know that there is a trivial solution, a trivial result that we can return from this function, and it will be return just 1. Okay, and I'm not using here if num is less than 1 because we will assume that this number that the user provides to this function will be greater or equals to 1. So at this point we know that there is our stopping condition when we reach 1. So we will have here 3 function calls. So the first function call will be with num equals to 3. And the function will return 3 plus sum up to 2, okay? And then we will call the function sum up to 2 with num equals to 2, right? Because we want to return the result for this function and we don't know it yet. So the result of this function will be 2 plus sum up to 1, okay? And also, we are going to call this function when num equals to 1 in a recursive manner. And in this case, we will see that the result of this function, sum up to 1, num equals to 1, and we know that here, if we take a look at our stopping condition, if num equals to 1, the function is just going to return 1. So this function for sum up to 1 will return 1. So instead of this one, we are going kind of backwards, right? Right now, we are going, instead of this function, we are going, because we found the solution, we are going to specify 1. So for sum up to 2, we know the result will be 3. So instead of this 2 plus 1, we are going to specify here 3. And for sum up to 3, which is this case, we are going to return 6. And this result is going to be returned here instead of this line, instead of this function call, there will be just 6. So the result variable will hold right now 6. And let's actually see that that's what happened. Build and run it. So 3, we provided with the number 3, and we see that the result is 6. And if we want to test it out for 5, and we expect for 5 that there will be 15, and that's exactly what we can see on the console. So once again, just to go over this solution, this function solution, we wanted to write a function that will sum all the numbers from 1 up to given num, and we wanted to use a recursive methodology, let's call it like this, and we need a recursive function call that will be able to split a given problem to find the sum up to a given num to some smaller sub-problems. And we know that sum up to a given num is actually the num itself, some number, plus the sum up to num minus 1. Okay, so we know that's the recursive call. That's some rule, some guideline that we use in this recursive function. And also we've seen that if we want to stop at some point the recursive calls, we need to have a stopping condition, some base case. And in this case, we used a base case as num equals to 1 because we know that it's very trivial that sum from 1 up to 1 is just 1. There is no even math operations. So this is it for this video. I hope that's clear how the function calls itself from within it. We just call another instance. Think of it as just different block units that are calling one another and expecting to receive a result from the next one. So thank you guys for watching, and I'll see you in the next example.